Okay, so the last titration curve that we need to do is the 50 milliliters of hydrochloric acid with 0.1 molar, so the same molarity of sodium hydroxide. So the initial pH, since it's hydrochloric, which is strong, we can just assume that all of the H dissociates, so we just take the negative log of the concentration, which means my initial pH is 1. Halfway, I see I took 0.05, which is 50 milliliters, times, 0.05 liters times the molarity to get 0.005 moles. So halfway, I would have used half as much hydroxide, so 0.0025. And so all the hydroxide gets reacted, and I'm just left with the H+. And then I have to figure out the total volume. So I had 50 milliliters, and to get halfway, I needed 25 milliliters of hydroxide to be added. So that's where the 25 came from. So my total volume is 75. If we had a different concentration of hydroxide, we'd have to use moles equals molarity times volume to figure that out. But it was 0.1 and 0.1, so halfway would just be half of the total volume of acid. So when you do that, you find that the pH is 0.12. So we have a very strong acid, so even adding that much hydroxide doesn't really make a change to the pH, but then at the equivalence point the pH jumps to 7. Notice that we have the moles of acid always equal the moles of base, and at equivalence the A line always goes down to 0. That is always true. Okay? And then afterwards, 60 milliliters, we end up with 0.001 moles of hydroxide left over. And we have to take the pOH, and then we find the pH. So the graph ends up looking like this. Remember, our buffer would jump up. Our buffer jumped up here and gradually climbed, and then had a big jump, and its equivalence point would be like a little bit higher. Sorry, if they're the same concentration, it should have taken the same milliliters. Okay, but anyway, so the reason the buffer goes a little bit higher and then more gradual is because the conjugate base is present. So that's going to automatically raise our pH a little bit if there's some base in there with the acid. But when we say it resists the change of pH, we have a much smaller jump than we do with the acid. Okay, and remember, the buffer could resist if we added acid or base. So that's the other reason why a buffer is special and different. And the last point that is really important that you know is that in the buffer, the equivalence point pH is higher because at the equivalence point there's also some of the conjugate base present. Okay, I feel really bad that these milliliters are not the same, so forgive me, but if it's the same concentration, it would take the same milliliters to get to the equivalence point. But you get the general idea here from the graph about the differences between the two. Okay, happy studies. Bye.